Next time you heat something in a microwave, take a second to watch it. You close the door, press a button, and inside, your plate slowly begins to rotate in a quiet circle. It's such a normal sight that most people never question it. But here's the strange part. Why does the food need to spin at all? After all, the microwave itself isn't moving. The heat isn't coming from a flame. There's no fan blowing hot air around like in an oven. Yet the plate inside keeps turning. Slowly, steadily. Almost like it's part of some tiny machine ritual happening behind that glass door. And if you've ever stopped the microwave halfway through heating something, you might have noticed something interesting. One side of the food might be very hot. The other side might still be surprisingly cold. Which raises an even bigger question. If microwaves are supposed to heat food quickly and evenly, why would a simple rotation make such a difference? The answer actually goes deep into how microwaves heat food in the first place. Because despite the name, a microwave oven isn't really heating food the way a stove or oven does. There's no hot air. No heating coils touching the food. Instead, something invisible is happening inside the microwave. Something involving energy waves bouncing around the metal walls of the oven. And strangely enough, those waves don't spread heat evenly at all. In fact, if your food didn't spin inside the microwave, you might end up with a meal that's half boiling hot and half completely cold. So that slow spinning plate you see inside the microwave. It's actually solving a surprisingly tricky problem that engineers had to figure out when microwave ovens were first invented. And the reason behind it starts with something you can't see at all. To understand why the plate spins, we first have to understand what's actually happening inside a microwave oven. When you press the start button, the microwave doesn't create heat directly. Instead, it produces microwaves, which are a type of electromagnetic wave similar to radio waves or the signals used in Wi-Fi, but much stronger. These waves bounce around inside the metal walls of the microwave like tiny, invisible balls of energy. When those waves hit your food, they interact with water molecules inside it. Water molecules start vibrating rapidly, and that movement creates heat. That's how your leftovers warm up. But here's where things get weird. Microwaves don't spread out perfectly evenly inside the oven. Instead, they bounce off the metal walls and create what scientists call hot spots and cold spots. Imagine standing in a room where invisible energy waves are bouncing everywhere. In some spots, the waves overlap and become stronger. In other places, they cancel each other out. Inside a microwave, the exact same thing happens. Some parts of the oven get more microwave energy, while other parts get less. If the food stayed in one place the entire time, the section sitting in a hot spot would heat up quickly, while another part might barely warm at all. That's why sometimes when you microwave food without stirring it, the middle might still be cold while the edges feel extremely hot. Engineers needed a simple way to solve this uneven heating problem. And the solution turned out to be surprisingly clever. Instead of trying to control the chaotic bouncing of the waves inside the microwave, they decided to move the food instead. Once engineers realized microwaves create hot spots and cold spots inside the oven, they had a problem. They couldn't easily control how the waves bounced around the metal box. The reflections inside a microwave are complex and constantly shifting. So instead of trying to control the waves, they came up with a much simpler idea. Move the food. If the food slowly rotates, different parts of it pass through different areas of microwave energy. A section that was sitting in a cold spot eventually moves into a hotter area, and vice versa. Over time, this rotation spreads the heat more evenly across the entire dish. Think of it like warming your hands near a fire. If you keep one hand in the same position, one side might get too hot while the other stays cold. But if you slowly rotate your hands, both sides warm up more evenly. The microwave turntable works in exactly the same way. That slow, steady spinning ensures that every part of your food spends time in both the stronger and weaker microwave zones. And interestingly, the speed of that rotation isn't random. Most microwave turntables rotate at about 5 to 6 revolutions per minute. That speed is slow enough to keep the food stable, but fast enough to move it through the different heating zones efficiently. Without that rotation, heating would be much less predictable. Some bites of your meal could be extremely hot, while others might still feel like they just came out of the refrigerator. But here's something many people don't realize. Not every microwave actually uses a spinning plate. Some modern designs solve the problem in a completely different way. And it's a clever bit of engineering most people never notice. If you look inside most microwaves, you'll see the familiar glass plate slowly rotating while your food heats up. But interestingly, some microwaves don't use a spinning plate at all. Instead, they solve the uneven heating problem in a completely different way. Inside every microwave is a component called a magnetron. This is the part that actually generates the microwave energy that heats your food. In many modern microwaves, engineers added something called a mode stirrer. It sounds complicated, but it's actually pretty simple. A mode stirrer is basically a small metal fan-like device hidden behind a panel inside the microwave. As it rotates, it changes the direction that the microwaves bounce around the oven. Instead of the waves forming fixed hot and cold spots, the energy patterns constantly shift around the chamber. So rather than moving the food, these microwaves move the energy itself. The result is similar. Different parts of the food receive energy at different moments, helping the meal heat more evenly. This design is often used in larger commercial microwaves or some newer household models because it allows for more space inside the oven. Without a glass turntable taking up room, you can fit larger dishes more easily. Still, for most home microwaves, the spinning plate remains the easiest and most reliable solution. It's simple, inexpensive, and very effective. But there's one more interesting detail about microwave heating that many people notice and sometimes complain about. Even with the turntable spinning, some foods still heat unevenly. Even with the turntable spinning and the microwaves bouncing around inside the oven, you might have noticed something frustrating. Sometimes your food still heats unevenly. Maybe the edges of your meal are almost too hot to touch, while the center is still a little cold. So if the spinning plate is supposed to solve the problem, why does this still happen? The answer comes down to how microwaves actually travel through food. Microwaves don't penetrate very deeply. In most foods, they only travel about 2 to 4 centimeters inside before their energy starts fading. That means the outer layers of your food absorb most of the microwave energy first. The inside then warms up more slowly as heat moves inward from the hotter outer layers. This is why thick foods like a large bowl of pasta or a dense casserole sometimes heat unevenly. The outside heats quickly, while the middle takes longer to catch up. That's also why microwave instructions often say things like, stir halfway through. Let it sit for 1 minute before eating. When you stir the food, you move the hotter and cooler parts around, helping the heat spread more evenly. And when you let food rest after microwaving, the heat continues traveling inside the food, balancing out the temperature. So that quiet spinning plate inside your microwave isn't just there for decoration. It's a clever engineering trick that helps solve a tricky physics problem, making sure invisible waves bouncing around a metal box can heat your food as evenly as possible. Next time you watch your plate slowly turning behind the microwave door, you'll know it's not just spinning for no reason. It's quietly helping your dinner heat the way it's supposed to.